You're here because you want to master polymers and macromolecules with a University of Cambridge graduate. Hi, I'm Brendan, and I'm a University of Cambridge graduate who has been teaching chemistry to many students like you over the past 9 years. I'm also the founder of the Chemistry Institution, where we have helped many students improve in a short amount of time and achieve the grades of their dreams. Be sure to check out our website in the link in the description below so that you can download a free copy of the notes for yourself and use it to run through this lecture with me today. Macromolecules is the last chapter in your secondary 4 syllabus, and it is also the most widely tested organic chapter due to its mass applications industrially. Macromolecules or polymers are large molecules formed by joining many monomers by covalent bonds. An example of this is addition polymers from your addition polymerization reaction. We roughly ran through this in your alkenes chapter, so let's run through this again. The monomer you'll use is an alkene, so the typical name of the polymer is a polyalkene. So for example, your polyethene is actually formed from your ethene monomers. How it starts off is we have the ethene monomer, and there are two things we can mainly draw. One is a repeated unit, as shown over here, which is a single unit. A repeated unit is a single unit that is generally repeated throughout the whole polymer, or you will be drawing the structure of the polymer, which is polyethene, which is a single repeated unit but with an N over here, which shows there are N number of repeating units inside this polymer. Sometimes questions will ask you to find out the value of N, and you have to be exposed to these kinds of questions to get used to them. So what exactly happens during addition polymerization? One is your double bond is broken. Two, the percentage composition or the empirical formula of the polymer actually remains the same as the monomer because it is just multiple of the same repeating unit. And your molecular formula, the melting point and boiling point of the polymer is higher than the monomer because the size is much higher than the monomer. So your melting point and boiling point increase as your MR increases, and there's stronger intermolecular forces of attraction between the big polymers. Some of the advantages of plastic which you have to know include that it is light, it is non-fragile, it's also very cheap and durable. Disadvantages is that they are non-biodegradable, they take up landfill site for disposal, and they give out poisonous HCl gas when you try to burn them. Now let's get into the important part. How do we draw our addition polymer? Step 1, you always want to put the C double bond C in the same line, and all other bonds are put on top or below the C double bond C. Next, you want to break the double bond in the C double bond C to form a C single bond C. Then, you want to draw a bond before the left carbon and a bond after the right carbon. This actually forms your repeating unit. Then, if you need to draw the polymer, you have to take one repeating unit and draw a bracket across the left and the right bonds drawn in step 3. This, with an N at the bottom right, is the polymer. Let me show you how you can apply these steps in some example questions. This question here says draw the polymer form from the propene monomer. You're going to draw propene first. Search. Remember, step 1 is to put the C double bond C in the same line and everything else on top or below. So I want you to transform this. This is still the same propene molecule, but we just have C double bond C in one line. The H and the H are top and below, and this is H and the CH3 group. Next, to draw the polymer, you have to draw one repeating unit first. So this would turn into a C single bond C. Everything else remains the same. And you're going to draw a bond on the left and a bond on the right. This is one repeating unit. Since the question asks us to draw a polymer, we'll draw a bracket here and a bracket here, and write an N. That is your polypropene. How about a question here that asks you to draw the repeating unit when but1-ene undergoes addition polymerization? First, I'll draw but1-ene. You should be very familiar with drawing this by now. And I'm going to transform this such that the C double bond C is in the same line. Here, H and H. Here is a H and there's a CH2 CH3 group. And with this, I'm able to transform this. So I'm going to copy and paste this, but now the double bond becomes a single bond. Everything else stays the same. And next, I'm going to draw a bond on the left and the right. And that's your one repeating unit of your polybutene. There are also questions that will ask you to draw the monomer that have been used to form the following polymer. In this case, here you're given a sample or a section of this polymer, and we are going to find the repeating unit. As you can see, clearly the pattern is this is the repeating unit. If we know that this is the repeating unit, let's just redraw it out over here. All you have to do is copy and paste this repeating unit, and we have to work backwards to find the monomer. So we're going to remove the bonds on the left and the right. We're going to put back the double bond, and everything else remains the same. Sometimes you'll be asked to name it. To name this, you have to find the longest carbon chain. This is 3 carbons long. This is actually prop-1-ene. And there's a methyl group in the second position. So this is 2-methyl prop-1-ene. Condensation is the combination of small molecules with the removal of a much smaller molecule as a byproduct. And there are two main condensation polymers. One is a polyester and one is a polyamide. A polyester will typically use a combination of an alcohol functional group and a carboxylic acid functional group. This will be how you form the ester functional group, hence the term polyester. With this polyester and the ester linkage, all you need is the monomer to have another OH group and another carboxylic acid group, and then you can form a combination of one monomer with another monomer with another monomer with another monomer, and that's how the chain repeats itself. An example of this polyester is terylene, which is used to make clothing materials. Natural polymers that have the same linkage is fats in your body. They also have this ester linkage as well. If you don't have two different monomers with the same functional groups, another way is you can use the same monomer over here, but it has both the carboxylic acid group and the alcohol functional group, and then it can continue linking with itself over and over. So this is another example of how polyesterification is done. Your polyamides work almost similarly. Polyamides use a combination of your amine functional group, which is the NH2 group, and the carboxylic acid functional group to form your amide linkage right over here, a C double bond O NH group, and H2O comes out as a byproduct. This is an example of a polyamide form from two different monomers, where each monomer has two of the same functional group. An example of this polyamide is nylon, which is typically used to make your fishing lines and your parachutes. A natural polymer that has this kind of linkage is called proteins. They also have this amide linkage. Another way for your polyamide to be formed is if you use a monomer with both the amine functional group and the carboxylic acid functional group. Then it can just continue linking with itself. That is how your polyamides are formed. Let's move on to the steps on how to draw your condensation polymer. First, you have to note which functional group is reacting with which functional group in the monomers. For an ester, you need to know that there's an alcohol functional group that should react with a carboxylic acid group. If it's an amide, you should know that amine functional group is reacting with a carboxylic acid functional group. Next, you need to note what the monomer has. Does the monomer have both the necessary functional groups? If it is, you just jump to step 3. Or if it has two of the same functional groups, you should jump to step 4. So, if it has both the necessary functional groups, for example, this monomer has both the alcohol and the carboxylic acid functional group for the polyester, then you will look at step 3, where you want to position the alcohol group or the amine group to the side and the carboxylic acid group to the side, and you want to just do the ester reaction or the amide reaction to form the ester and amide group. Once that's done, you can draw that bond, and that will show your repeating unit. If it is a case where the monomer has two of the same functional group, for example, one monomer has two alcohol groups, the other monomer has two carboxylic acid groups, then the repeating unit is both of them side by side. So you need to position the alcohol group in one monomer to the side and position the carboxylic acid in the other monomer to the side, and then do the reaction and then form the bond. That is how you draw your repeating unit. Don't worry if this is all confusing. I'm going to explain it in some examples on the right later on. Once you've done either step 3 or 4, you just have to draw the polymer. This will be done by taking one repeating unit and you draw the bracket across the left and the right bond and write an N at the bottom right. Here are some example questions to help you better visualize this. And take note, you should probably relook at the steps for drawing condensation polymers and try to apply it to these kind of questions so you know what you're doing. After a while, you wouldn't really need to memorize the steps, as it would just come very easily. It's kind of like a pattern recognition question after you've done quite a bit. This first question says that you have to draw the polymer form from the following monomer. Here, you have a monomer, and first, you want to identify the functional groups. This is a carboxylic acid functional group. This is an alcohol functional group. In this case, this is going to form a polyester. And how do we draw this? Well, you know that this monomer has both the necessary functional groups. So you will jump to step 3, which says that you just have to remove the necessary parts. So for this C double bond O, it's going to remove the OH. Everything else here remains the same. Then for the OH, you remove the H. And just like that, this is, when you remove these out, H2O comes out as a byproduct, and this is one repeating unit. To draw the polymer, you just have to put a bracket like this, write N, and that is your answer right here. What if you have to draw two repeating units of the following polymer that is formed from the following monomers? First step, look at the functional groups. There's a carboxylic acid group, and then there is this amine group over here. So this is a step 4 scenario where you will have to form your polyamide by linking these two monomers together to form this one repeating unit. First, you're going to remove the OHs from the C double bond Os. And then it's going to link with the NH group. And these NH2s are going to remove a hydrogen. And everything else remains the same. Next, you draw a bond on the left and the right of this. And this is one repeating unit. Oh, they ask you to draw two repeating units, so you do have to repeat this. So I'm just going to move this slightly to the left, and we're just going to redraw the same thing. When you draw two repeating units, it also shows how the linkage will occur. And draw slightly smaller as well, but you get the idea. As you can see, there is these two linkages, and this, I'm just going to box this up, is one repeating unit. So repeating this box one more time will show you two repeating units of this polymer. Next, you need to draw out the monomer sometimes from a polymer that is given. Here you have to identify the linkage and work backwards. In this case, this is clearly an amide linkage. So this is an example of a polyamide. And if you look at this kind of polymer, definitely has two different monomers over here. One with both the carboxylic acid functional groups and the other with both the amine groups. So what you're going to do is you're going to split up the linkage here and just form back the monomers. The C double bond O clearly should be separated out, and you want to put back the OH that was a part of this carboxylic acid group. This is monomer A. For monomer B, the NHs are going to come out. And you're going to plug back the H that was part of this amine group. And there you have it. You have both the monomers, monomer A and monomer B of this polymer. That's all for today's video. If you really learned something and you like this video, be sure to click on that like and that subscribe button so you don't miss out on free content like this. If you want to join my community of students at the Cambridge Institution, be sure to check out our link in the description below so that you can sign up for a free trial class today. Here you can learn the exact systems that we use at the Cambridge Institution to help our students improve in a short span of time and also achieve their grades of their dreams in the end.